Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more to share anywhere you see our video, and also subscribe. If you have not subscribed before, you can press on your subscribe button so that you can get direct updates from us. And in this platform, we have over 250 videos. It means you can come here and learn any topic of your choice: mathematics, physics, and chemistry. If at all any topic you are expected to be there and is not there yet, you can leave a comment below, or you reach us with this number. Now with this line, you can call us, you can WhatsApp us, and also Telegram is allowed. Either anyone. Okay, what I have for you, I have cell. In our previous video, I've explained current, the connection, the resistors, Ohm's laws, and I've given it. I'm also showing. I've shown example on how to find current, which you should make sure you view our first video, which is video before this. Is very, very important. Now, what I have for you on this video, I have what is called cell in series, cell in parallel, and problems. This problem will involve both resistors and cells in cell. By the end of this video, you should understand this theory outline. Now, let's start. Okay. Now, when we hear a word, let me start from cell in series. Cell in series. Now, I'll be having something like this. Now, that's what cell is. Now, we have E1, R1, E2, R2, E3, R3. Now, that is what my cell is all about. I told you, we all know what's called battery. Anyway, now, for cell connection, for cell connected in series, the total electromotive force, please take note of that, is E equals to E1 plus E2 plus E3. Total electromotive force. It means E is talking about electromotive force. Now, that is what I want you to understand. Now, and the resistors. Let's talk about the resistors. Now, the resistors also will be the total resistors. Total internal, because we have internal resistors this time around. Total internal resistors, it will be R equals to R1 plus R2 plus R3. That is what we are talking about. Now, please take note of that. Electromotive force, that is what is called EMF, electromotive force. Now, let me explain the one of cell in parallel. Cell in parallel. Now, cell in parallel, it's always like this. Now, I have 1, I have 2, I have 3. Now, that is all about that. Now, this one will be E1, R1, E2, R2, E3, R3. Now, that is what is called cell in parallel. That is always, that's how it always looks like. Cell in parallel. It means the total electromotive force will be the total electromotive force, which is E, will be E1 equals to E2 equals to E3. That is just what we are saying there. Why the total internal resistors, will be, or resistance will be 1 all over R equals to 1 all over R1 plus 1 all over R2 plus 1 all over R3. Now, anytime you see small r, we always denote it by what? Internal resistors. When it is big R, it means external resistors. Please take note of that, which you can do your manipulation and do some things which you can see that I've told you earlier. 1 all over R can be equals to R1, R2, R3, all divided by, this one will be R2, R3 plus R1, R3 plus R2, R1, which I have my R equals to R1, R2, R3 divided by R2, R3 plus R1, R3 plus R2, R3. Please take note of that. Now, it means it's okay, mathematically, it's balanced here. Now, with this, you can see the connection in series and connection in what? Parallel. This for series, why this for what? Parallel. And take note of this condition that my electromotive force, when it's series, is equals to the what? Sum of each resistors. And the total internal resistors also is equal to the what? You have to sum it up. Why cell in parallel, which I've told you earlier, the electromotive force are equal to the E are equal to themselves, while the total internal resistance are in this form. Now, I think it's time to go to solve 1 or 2 problems on this part. Okay, it's time to solve 1 or 2 problems. Now, I have this problem. Okay, let me start from what is the effective resistance of the current, of the circuit, Now, let me explain something for those that are, when you hear word resistance, it means we are talking about more than one resistors. Are you getting what I'm saying now? Please don't take, if it is resistor, it means only one. Resistant, accumulation of what? Resistor, which is singular and plural. Now, resistant. Okay, now accumulation of resistors will generate what? Resistance. And please take note of that. Normally, we can say that we have resistors. It means we are talking about more than one resistor. I mean, one resistor. But when it accumulates, it will become what? Resistors. Now, I want to have this question at hand. What is the effective resistance of the circuit? Which is, the circuit goes this way, and also goes this way. And also goes now. It must flow. Now, let me use this as 5 ohms. I have this as 10 ohms. I have this as 2 ohms. I have this as 4 ohms. Now, that is what I'm having here. Now, look at this. These are series, which I've explained in our previous video. This one is only one connection and series, but why this one is parallel? Now, how do I solve this problem? The first thing is, I must learn to resolve. Now, it means, let me call this one Rx, and let me call this one, what is there, Ry. You can denote it anyhow in your own, as far as convenient for you. Now, the first thing I will do, my Rx will be equals to, my Rx are in series, which I'll be having 5 ohms plus 10 ohms, which it will be, my Rx will be equals to what? 15 ohms. Now, that is first thing I will do. Now, the next thing I will do now is, I will also resolve this one to what? To 1, which is, my Ry will be, is in form of a what? Which, let me call it in terms of 1 over Ry equals to 1 over 2 plus 1 over 4, which I've explained this in our previous video, which my Ry, 1 over Ry equals to 4 plus 2 divided by, the LCM is what is, I don't need to stress myself, the LCM is 4 and 4 in 2, that will be 2 times 4 and 2 plus 1, which I'll be having 3 all over 2. 3 all over 2. I mean 3 all over 4. I'll be having 3 all over 4. Okay. Which the same thing as 1.33 ohms. Now, I've tried to resolve it. Now, for me to get my full mark, maybe in any exam, what I will do, I'm expecting you to do it this way. Redraw your connection. Redraw it this way. Now, you have balanced it up. Now, everything here we call it Rx, and everything here we call what? Ry. Now, it means my Rx and my Ry are already given, which is, I have 15 ohms, and I have my what? As this is 1.33 ohms. Now, since I have it, what are you looking at? You are looking at what is called series connection. Already a series connection. It means what all I'm looking for, which is my R, it will be equals to Rs plus Ry. I'm just denoting with Rx and Y for it to be convenient for me to work upon. It means my resistance is to be equals to 15 ohms plus 1.33 ohms. Now, whatever I have, it means my answer will be 16 point. My R equals to 16.33 ohms. That is all. That is all. Can you see? Very straightforward. Very, very straightforward. Now, let me try to generate another problem that will help us. Okay. I have this connection. I want to, what is the effective resistance? What is the effective resistance of the circuit also? Now, how my circle goes is, let me make this one to be tedious a bit. Once it's even too long. It need to be too long. My body is very small. Please, we need your help. Please, you can donate with all to us. Or we need to buy board. Now, this is yes. Now I have this connection. Let me put number of them. This one will be 1 ohms. This one will be 2 ohms. This one will be 2 ohms. This one will be 2 ohms. This one will be 1 ohms. And this one will be 3 ohms. That is what I have. Now I want to calculate this particular problem. How do I go? Now it's very, very simple. Very, very simple. Now, not something, these are connection anyway. From here to here is one connection. From here to here is in series. I mean, from here to here is series. Because of what? Why am I saying in series? It is connected by what? Only one wire. Can you see only one current? Now, since is that, it means I can call this one R1, R2, R3, which is, I can denote it by calling it Rn. Sorry for that. I can use it as Rn. Now, it means my Rn, because it's a series connection, it will be equals to R1 plus R2 plus R3. Now, it means my Rn will be equals to 2 plus 2 plus 2, which everything will be equals to what? 6 ohms. Okay, for those that are still trying to cope, I can redraw this, my circuits, by having 1 ohms and move on and produce another. We call it R1. Don't forget, I call it 6 ohms now, which is also known as what? Rn. Come back to this place and having a connection of 3 ohms, and I have another one which is 1 ohms, and I have it this way. Now it means successfully this my Rm become 1, which is my Rn. It become n. Now what else can I do? Now I can also do this also. Do you know that these two are in parallel? These ones, you can't touch this 1 ohms, 1 ohms. Because of what? Now, but these two, they are in parallel. It means I can say that since they are in parallel, I can redraw it by having my this connection. My R will I give you? Tell me what. Okay, let me have Rp. Now my Rp will be equals to 1 over Rp equals to 1 all over 3 plus 1 all over what? 6, which I've explained to you before. Now, it means I can say that 1 all over Rp equals to 6 plus 3 divided by 18, which I'm finding the LCM. 1 all over Rp equals to, we have 9, which is I have 1 all over 2. 1 all over 2. Now it means my Rp, it will be equals to what? 2. Since 1 is equals to 1, then Rp equals to R1. Now it means now I can also redraw it by having 1 ohms, which is known as my R1, which is ohms. This is ohms. 2 ohms, which is, we call it Rp. I have another 1 ohms. Back to the source. Now, can you see? I'm now having only one connection. I'm having only one connection. It means, since it's not a road where one connection, it means the R, I'm having only one power, only one current, which it will be equals to 1 plus 1 plus 2. 1 plus 1 plus 2, which I'll be having, what again? 1 plus 1 plus 2, which I have 4, equals to 4 ohms. That is what I'm looking for. That is all. That is all. That is all. Now, let me show more example on this part. Let me show one more example on this part. Now, look at this question. A car fuse is marked 15 ampere and operates normally on a 12 volt battery. Calculate the resistance of the fuse wire. Now, solution to this problem is a very simple one. You can see it anywhere. Don't forget that what my this equals to I of R, potential difference. Now it means my R is 15 ampere, my potential difference, which is known as V, is 12 volts. Potential difference, which is called PD. Now, since I have that and I'm looking for my what? What is my what? Resistance. I'm looking for what? Okay. Calculate the resistance. It means my R equals to V all over I, which I have my R equals to 12 divided by 15, which I have my R equals to 0.8 ohms. Please take note of that. 0.8 ohms. Now, 0.8 ohms. Okay, look at this question also. Now, I have this question. I have 5 ohms. I have 10 ohms. Electromotive force. And I have another connection like this. I have 10 ohms. Now, this is the question. Now, look at this question. I want to calculate the resistance. Calculate the resistance and current. Now, we are looking for resistance and current. Now, which taking my, okay, if I have it this way, and I have this, let me call this place Okay, now I want to calculate my current also. It means I will call this place, let me call it 12 volts. 12 volts is not bad. Now, look at this question. The first thing I'll do, this in series, I will calculate my series. It means call it R naught. It will be equals to 5 plus 10, which is equals to 15 ohms. R naught equals to 15 ohms. Now, the second thing, this will now become parallel to themselves. It means I'll have it, my R, which what I'm looking for, 1 all over R equals to 1 all over 15 plus 1 all over 10. Hope you can understand, which my LCM will be what? Okay, I'll be having it R equals to 150 divided by 25, which is equals to 6 ohms. My 6 ohms. Now, how do I calculate my current? Hope you know that we have I1, I2. There are two currents flowing. I1, I2. It means the total current will be equals to R1, R2 plus R1. Anyhow you work it out, which is also known. And my current is always equals to potential difference divided by what? The total resistance. Total R, which is, I've explained that. It means, what is my current? It means my current will be, now it means I'll have my current, and now my current will now be 12, which is going to be 12. Okay, let me call, yes, 12. Potential difference is 12, which is 12 divided by what? By 6, which is 2 ampere. Which is 2 ampere. Now, since I have it as 2 ampere, I cannot continue. That is all I have. That is all what I have. Oh, I wish I can do one more of these plates, of these examples. And let me see, maybe time will permit me. Okay, now let me quickly show more examples on this part. Now, if I have a problem this way, sorry. Now, I have this as a 13 ampere. I have this as 2 ohms. I have this as, let me put it inside, 2 ohms, and I have 3 ohms. I have 4 ohms. Now, and I have the direction this way. How do I calculate this? Calculate the current in the in 13 ampere resistance. Shows in the diagram. Now, it means, how do I go solution? This is without looking at it, without stressing myself. I know it's a parallel connection. It means all what I know about parallel connection is always equals to R1 plus R2 plus R3, which I've explained earlier. It means I'll be talking about 1 all over R1 equals to 1 all over 2 plus 1 all over 3 plus 1 all over 4, which I've explained earlier. If I like, I can leave it like this, find it, but it's good to do it this way. 1 all over R equals to, we have 6 plus 4. LCM will be what? Let me use LCM of let me use LCM of 12. Yes, 12 goes in everything. Now I have 6 plus 4 plus 3. Now, which also will be equals to 13 all over 12 ohms. 13 all over 12 ohms. Now, since I have it as 13 all over 12 ohms, I cannot continue that what? My V, which is my V, my voltage equals to IR. Now, since I know that I'm looking for what? My voltage. Now, I'm looking for my what? Okay. Now, I'm looking for since I have it this way, I can look at it. Okay, this current I'm looking for voltage. This is current I'm looking for voltage. Calculate volt, sorry. Potential difference. Anyway. Now, since I have it, it means I'm talking about V equals to what is my I? My I is 13 ampere. It means 13 multiplied by I've not finished it. I've not finished this. My resistance will be equals to 12 all over 13. Please, inverse of this number, ohms. Please, it means it will be 12 all over 13, which this will cancel this. It means my volt equals to 13. That is all about that. You can see how it is. You know how I have to stop here. Don't forget that you are on with Further Solutions Academy. Encourage us more to share anywhere you see our video, and if you have not subscribed, please, just please, if you are enjoying the video, just try to subscribe so that you can get direct update from us, and you can leave a comment below if there is need for, or you reach us with this number. You can reach us with this number. With this number, you can call us, you can WhatsApp us, and Telegram is allowed. Once again, thanks for watching.